In this video, I'll be talking about how to make a collinearity matrix, which is the base for regression. Here, I've used data which has age, gender, chest pain, blood pressure, cholesterol, blood sugar levels, the maximum heart rate, old peak, and the presence or absence of heart disease. For the sake of the correlation matrix, I've included the continuous data variables such as chest pain, blood pressure, maximum heart rate, and I'm using Pearson's R correlation coefficient. If your data is ordinal or non-normal, then use Spearman's and make sure the data points are more than 30. If your data points are less than 30, then use Kendall's tau B correlation coefficient. And it does not matter if the data is normal or ordinal, you can still use Kendall's tau B correlation coefficient, even if regardless. Anyways, so getting started with the correlation matrix, the factors that I choose are chest pain, blood pressure, maximum heart rate. I can add in another factor saying cholesterol and it will show up in the model. So here, we are basically trying to establish a relationship between blood pressure and chest pain. The value of P is greater than 0.05, which means we have to accept the null hypothesis. So there is no relationship between blood pressure and chest pain. So we don't look at the R value over here. Now let's skip to max heart rate and chest pain. Here the value of P is significantly less than 0.05, which indicates that there is a relationship between maximum heart rate and chest pain as we're accepting the alternative hypotheses. Here, let's talk about Pearson's R and what it indicates for a second. It's the measure of strength and direction of linear relationship between two variables. It's a number between -1 and 1 that indicates how closely two variables are correlated. A value of 1 indicates a perfect positive correlation, meaning that the two variables are always increasing or decreasing together. And a value of -1 indicates a perfect negative correlation, meaning that the two variables are always moving in opposite directions. A value of 0 indicates that there is no linear correlation between the two variables. So here, the value of R is 0.299, which is close to 0. However, it is a positive value, and that means there is a slight positive relationship between maximum heart rate and chest pain. Here, when we look at cholesterol and blood pressure, the alternative hypothesis saying that there is a relationship is accepted, and the value between them is 0.136. For the Pearson's R. So it means that there is a slight positive relationship as well. Now here, for example, when the for cholesterol and chest pain, here the null hypothesis is rejected and the alternative is accepted, that there is a relationship. Here the value is negative. A negative value indicates that there's a negative relationship between chest pain and cholesterol. However, the value is very close to 0 and it's quite marginal. So we can say there's a slight negative relationship. And that's how you can analyze the relationship between different kinds of variables in the data set using the correlation matrix.